Now let's look at products of vectors. And there are two types of products, dot product and cross product. Now let's say we have two vectors, O, A, represented by vector A, and B, let's say this is vector B. Now, multiplying these vectors would be easier if we could somehow make it along the same direction. Yes. So one of the ways of doing that is by projection. So projection of OB on OA. So basically what we do is from the terminal point of vector B, we drop a perpendicular to vector A. And let's say this is M. So now OM is the projection of OB onto OA. Now, what would be OM? How do we evaluate OM? If you look at it from a trigonometric ratios point of view, OM is the adjacent point, adjacent side of this angle theta, right? So, adjacent side comes in cos. So cos theta is equal to adjacent side by hypotenuse. What we want is OM. So OM is equal to OB cos theta. Now this OM and OB are in the same direction. So it's just a question of the magnitudes being different. So we can say vector OM is equal to vector OB cos theta or B cos theta. Vector A dot vector B would be equal to OA times OM. Now OA is magnitude of A and OM is going to be magnitude of B cos theta or magnitude of B cos theta, because cos theta is a number which doesn't have any direction. So the dot product is magnitude of A, magnitude of B times cos theta. So that is the dot product. Now let's look at some properties of the dot product. A dot B is a scalar. Remember, magnitude of A is a scalar quantity, magnitude of B is a scalar quantity, and cos theta is a real number. So the product would be a scalar. Now we know A dot B is equal to magnitude of A, magnitude of B, cos theta, or in other words, cos theta is equal to, that is the angle between the two vectors would be the dot product divided by magnitude of A and magnitude of B. Okay, if theta is equal to pi by 2, that is 90 degree, that is perpendicular to each other. Vector A is perpendicular to vector B. Cos theta equal to 0, we know that, which implies that the dot product is going to be, much more importantly, if you look at it from the other side, it makes more, becomes more useful. If the dot product is 0, implies that the vectors are perpendicular to each other. That means vectors are orthogonal. Now vector A, vector B is equal to magnitude of A times magnitude of B cos theta. Now these are magnitudes, right? That means they are just numbers. And multiplication of real numbers are commutative. That means we can write it as B A cos theta, which means cos theta. So that means dot product is commutative. Now what about vector A? Dot vector A. Again, magnitude of A cos theta. Now here theta is 0. Cos theta is 1. So which means we can write this as square. Or in short we can just say square. Since cos theta equal to 1. In this case the magnitudes were equal. Now let's say the magnitudes are not equal. So let's say A dot B. Now if they have the same direction, then we can say A dot B is equal to magnitude of A, magnitude of B. Why? Because cos 0 is 1. Now, if it is opposite directions, then in that case, magnitude of A, magnitude of B minus. Why? Because cos pi is equal to -1. Okay, so now that we know this, let's look at the unit vectors. I times I cap dot I cap is equal to what? Is equal to I cap square, which is equal to magnitude of I cap square is equal to 1. Which means this would be the case in all the other 3 cases as well. And K. What about the dot product of Ij, Jk? So I cap dot J cap would be magnitude of I, magnitude of J cos pi by 2. Remember, this is I, this is J, this is K. Unit vectors along the 3 axes. Now cos pi by 2 is 0. So I cap dot J cap is 0. Similarly, J cap dot K cap equal to 0. And similarly, I cap dot K cap equal to 0. MA dot B is equal to A vector A dot vector B. Now let's say vector A is in the Cartesian form. A1I plus A2J plus A3K. Vector B is equal to B1I plus B2J plus B3K. Now vector A dot vector B would be equal to A1I plus A2J plus A3K dot B1I plus B2J plus B3K. Now A1I dot I plus A1B2IJ plus A1B3IK plus A2I, this should have been A1B1, A2B1 J dot I plus A2B2 J dot J plus A2B3 J dot K plus A3B1 K dot I plus A3B2 K dot J plus A3 B3 is K dot K. Now in this we know I dot I is 1. So A1 B1. Now I dot J is 0. I dot K is 0. So this gets cancelled, this gets cancelled, this gets cancelled. We are left with A2 B2. J dot J is 1. This gets cancelled, this gets cancelled, and this gets cancelled, and we are left with A3 B3. K dot K is 1. So this is so basically just multiply the like to like. So I to I, J to J, and K to K in case of a dot product. Vector A dot vector B plus vector C is equal to vector A dot vector B plus vector A dot vector C. What is this? Distributive over addition. Okay, 10th one. What about this? The magnitude of the sum square is equal to what? We can write this as A plus B dot A plus B. Magnitude of A square plus A dot B plus B dot A plus magnitude of B square. This is equal to magnitude of A square plus 2 times, because they are commutative, right? Dot products are commutative. So A dot B, B dot A both mean the same thing. So 2 times A B plus magnitude of B square. Now which means A plus B plus C square would be equal to what? Magnitude of A square plus, we'll take this like this. So magnitude of A square plus magnitude of B plus C square plus 2 times vector A dot vector B plus vector C. Vector A square plus B plus C square. Again, previously we have seen that. So magnitude of B square plus magnitude of C square plus 2 times B dot C plus 2 times vector A dot B plus C, and this is, we can distribute it. So B plus 2AC, which means we can now simplify plus B square plus C square plus 2 times, common to all three, AB plus BC plus AC. So that is dot product. This is going to be very helpful to you later. Makes a lot of things very easy. Bye for now.